Section 2.2 Trigonometric functions of non-acute angles. Reference angle. A reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. I want you guys to highlight this one, terminal side of angle theta and the x-axis. So when I give you guys an angle theta, you need to know how to find the reference angle. Okay, let me show you some example. Okay, look at this 4 case. First case, if my theta is in quadrant 1. So I want to find the reference angle. Reference angle is talking about it's gonna be made by the terminal side. This line will be the terminal side. And the x-axis. So this is gonna be the x-axis. So the angle in between terminal side and the x-axis. So here, that will be my terminal angle. So this way means theta equal to reference angle. Okay, second case, when your theta is in quadrant 2, okay, the reference angle will be formed by the terminal side and the x-axis. So this one, that will be the reference angle. So if I want to find the reference angle, that will be 180 minus theta. Okay, case 3, when my theta is going to be on quadrant 3. Okay, quadrant 3, so the reference angle will be the terminal side and the x-axis. So this angle, that will be my reference angle. So my reference angle will be equal to theta minus 180. Okay, last case, when my theta is going to be in the quadrant 4. So my reference angle will be formed by terminal side and the x-axis. So this is going to be my reference angle. So my reference angle will be equal to 360 minus theta. Okay, right? Reference angle theta pi for theta. When your theta is in between from 0 to 360 degree. Okay, I just show you guys how to find the reference angle. Okay, in this 4 case. Example 1. Find the reference angle for an angle of 218. Okay, 218. So think about it. Which quadrant is it? That would be quadrant 3, right? Because greater than 180, but less than 270, so it will be quadrant 3. So when we have the quadrant 3, how can we find the reference angle? We'll be using the theta 218 minus the 180. Okay, that will be equal to 38 degrees. Okay, B. Find the reference angle for an angle of 1387. You could see this theta is greater than 360, right? So what we're going to do, we want to find the coterminal angle. Remember what's a coterminal angle? You could add or subtract the 360. Okay, so 1387, you could try to subtract 360. It's still greater than 360, right? So keep subtract 360 until your angle is within from 0 to 360 degree. So I find it out, you need to times 3. Then you're going to get 307 degree. And then 307 degree, that will be in quadrant 4, right? 1, 2, 3, 4. Okay, quadrant 4, 307 degree. How can we find the reference angle? We're going to use a 360 minus 307. Okay, the picture is going to be looks like this. Okay, one more time. When your angle is not in between from 0 to 360 degree, you need to find the coterminal angle. Either plus 360 or minus 360. Until your theta is between from 0 to 360 degree. And then, depends on which quadrant of your theta, you're going to find your reference angle. Example 2. Find the values of the 6 trigonometric function for 210 degree. Okay, 6 trigonometric functions. Let's do it together for this one. Okay, 210. So you're gonna know that will be in the quadrant 3. Okay, this is gonna be 210 degree. So first, we're gonna find out the reference angle. Okay, so this is gonna be my reference angle equal to 210 minus 180. So you should get 30 degree. Okay, so now you know that will be 30 degree. And then we want to find the 6 trigonometric functions. So here there will be 30 degree. Okay, and then I'm gonna form the triangle here. It's a 90 degree. So if this is 90, this is 30, this guy will be 60 degree. Okay, remember this 30, 60, and 90 special triangle? We learned it from the session 2.1. Okay, you should remember like the sign in here. So you should have 2, 1, and then square root 3. Okay, but this is a x-axis, this is a y-axis. So this x-axis here should be negative. So I should have a negative square root of 3, and this is gonna be negative 1. So this is gonna be your point. You could put negative square root 3 and negative 1. Okay, now we do have this triangle. Go back to my PowerPoint here. So this is how we find the reference angle. After we have the reference angle, then we could have the triangle here. Okay, and then you remember that the special triangle R equal to 2, x equal to negative square root 3, and y equal to negative 1. Okay, right? So now we're gonna find the 6 trigonometric values. So first, sine 210, that will be equal to y over r. Okay, y over r, which is gonna be negative 1/2. Cosine, that will be x over r. So that will be negative 3 over 2. Okay, I want you guys try find tangent, cosecant, secant, and cotangent. Okay, check your work. Tangent, that will be y over x. So you should get negative 1 over negative square root 3. And then rationalize. You're going to times 3 over 3. So you should get 3 over 3 here. Cotangent, you're going to reciprocal of this guy. So that will be equal to 3. Secant, that will be rationalized. Secant, that will be reciprocal of cosine. So that will be 2 over negative square root of 3. And then rationalize, you're going to get negative 2 square root 3 over 3. Last one, cosecant is going to be reciprocal of sine. So that will be equal to negative 2. Okay, one more time. When they given like the angle, first try to find the reference angle. If that is a special angle, means like 30 degree, 60 degree, or 45 degree, you should be able to tell what is your x, y, and then r. So based on this triangle, then you're gonna find the 6 trigonometric function values. Finding trigonometric function values for any non-quadrantal angle data. Remember this guy? Quadrantal angle, talking about 0 degree, 90, 180, 270, 360. Now we want to find any non-congenital. So it's not 90, 180, 270, 360. Step 1. If theta greater than 360 degree or if theta less than 0 degree, find a coterminal angle by adding or subtracting 360 degree. As many times as need to get an angle greater than 0 but less than 360. So make sure your angle has to be in between 0 to 360 degree. If not, find the coterminal angle. You could do plus minus 360 degree. Okay, this is a step 1. Step 2, find the reference angle. Okay, try to graph it out to see which quadrant is your theta located. Step 3, find the trigonometric function values for the reference angle. Step 4, determine the correct size for the value found in the step 3. This gives the values of the trigonometric function for the angle theta. Okay, let's try do it together. We do have a cosine negative 240 degree. So the theta, this is not within from 0 to 360 degree. Okay, so what we're gonna do, we're gonna find the coterminal angle. Okay, we're gonna do cosine negative 240. This is a negative, so we're gonna do 360 degree here. So that will be cosine 120 degree. Okay, and then 120 degree, that will be in the quadrant 2. So we're gonna find out the reference angle. Reference angle will be equal to 180 minus 120. That will be equal to 60 degree. Okay, after that, we know the reference angle is equal to 60 degree. Okay, remember we learned it from the chapter 4, the cast CAST, right? This is talking about all the trigonometric functions in quadrant 1 will be positive. This is only sine and cosecant. This one is going to be tangent and cotangent will be positive. The last quadrant here, there'll be cosine and secant will be positive. Right now, my cosine theta is going to be located in the quadrant 2. So cosine in the quadrant 2, that will be equal to negative. Okay, so that will be cosine 120 will be equal to negative cosine reference angle, which is going to be 60 degree. Okay, right? Okay, remember the triangle? 60, 30, you have a 1, 2, square root 3. Okay, cosine 60, that would be equal to 1/2. Okay, cosine 60, that will be adjacent over hypotenuse. So that will be equal to negative 1/2. Okay, check the work here. Oh, they use the angle negative 240. They starting like clockwise. Okay, and then find the reference angle. That's about like the same thing. Okay, it's also equal to cosine 120. And then reference angle is 60. Cosine in this quadrant will be negative. So negative cosine 60. And that will be equal to 1/2. Okay, negative 1/2. Good. Okay, B. Can you guys try to do it? Make sure you find out the data that will be in between from 0 to 360 degree. And then try to graph it out, find the reference angle. And then determine the tangent in that quadrant will be positive or negative. Okay, check the work. You're gonna subtract 360, right? Then you find it out, that will be 315 degree. which is gonna be in the quadrant 4. Okay, and then you're gonna use 360 minus 315. That will be your reference angle, 45°. Okay, so tangent 675 will be equal to 315. Okay, first find out the angle is in between from 0 to 360. And then tangent in quadrant 4, that will be negative. So that will be equal to negative tangent 45. What is the tangent 45 equal to? That will be equal to 1, right? So that will be negative 1. On the exam, please show me all your work. Don't just give me the final answer. Okay, you need to show me all your work, how you find the coterminal angle, how you find the reference angle, and then what's gonna be equal to. Okay, example 4. Using function values of the special angles, evaluate cosine 120 plus 2 sine squared 60 minus tangent squared 30. Okay, let's do together here. Cosine 120 plus 2 sine squared 60 minus tangent squared 30. Okay, cosine 120. That will be in the quadrant 2 here. Alright, so what is the reference angle? Reference angle will be here. So 180 minus 120, which is going to be 60°. And then one more time, cosine in this quadrant is a negative. So I'm going to get negative cosine 60°. And then plus 2 sine 60. I just take out the square here. Same idea for this guy. Okay, cosine 60, that will be 1/2. And then sine 60, that will be roughly over 2. Take square. And then tangent 30. Tangent 30 will be opposite over adjacent. Okay, so that will be negative 1/2 plus 3 over 4. And then that will be 1 over 3. Okay, simplify it. Divided by 2, divided by 2. Okay, then get the same denominator, which is going to be 6. So you times 3 here, you're going to times 3 here. You times 3 here, you're going to times 3 here. You times 2 here, you times 2 here. Okay, so that will be 6 minus 2, which is going to be 4 over 6. Simplify it, 2 over 3. Okay? Check the work. Okay, example 5. Evaluate cosine 780 by first expressing the function in terms of the angle in between 0 and 360. 780, we need to find the coterminal angle. So pretty much we need to minus 360 2 times, right? So that will be cosine 60°. And then cosine 60, that will be 1/2. Okay, B. Cotangent negative 405°. So you're gonna add 360. Again, you're gonna be adding 2 times 360, right? So you're gonna get cotangent 315 degree. Find the reference angle, okay? So 360 minus 315, that will be the reference angle. And then cotangent in the quadrant 4, that will be negative. So negative cotangent 45. Cotangent 45, that will be equal to 1. So that will be negative 1. Make sure show me all the work on the exam, okay? Example 6. Find all values of theta if theta is in the interval from 0 to 360 and cosine theta is equal to negative rad 2 over 2. Okay, since cosine theta is negative, so theta must be lying in the quadrant 2 or quadrant 3. Okay, and then the absolute value of the cosine theta is rad 2 over 2. So the reference angle is 45 degree. Okay, you could look back like the triangle, right? Rad 2 over 2, it has to be 45 degree. Okay, so when your angle is in the quadrant 2, reference angle is 45, then your theta should be 180 minus 45, which is going to be 135 degree. But if your angle is in the quadrant 3, so somewhere like here, then the angle will be 180 plus 45, which is going to be 225 degree. That's it.